Let us take the next problem. Find the equation of the best fitting straight line for the following data and hence estimate the value of the determinant value of the dependent variable corresponding to the value 30 of the independent variable. Now let us see the given data. This is the given data, the values of x and the values of y. Let y is equal to ax plus b be the equation of the best fitting straight line. In the question, they have not given any particular equation. In that case, we can take any of the two forms of a linear equation which we have seen earlier. For now, let us take the equation of the form ax plus b. For this linear equation, we have taken the two normal equations which we know already how to write. Here n is 5 because the number of observations is 5 in the given data. Now let us form a table. So this is the required table which we require in the normal equations. Let us substitute all these summation values in the normal equations. Yeah, we have substituted here. If you use the scientific calculator, we can find the values of a and b from these two equations. The values of a and b will be this: a is equal to 0.7 and b is equal to 12.3. Then we substitute these values of a and b back in the linear equation which we have considered. The value of a will put here and the value of b will put here, so that our equation will be y is equal to 0.7 x plus 12.3. Also they are asking to find the value of y when x is equal to 30. So let us substitute in the place of x 30 and simplify to get the answer 33.3. Now let us consider the next problem. The problem is a simply supported beam carries a concentrated load P. So we got one variable which is P. At its midpoint, corresponding to various values of P, the maximum deflection Y is measured and is given in the following table. So here Y is the dependent variable and P is the independent variable. That is, in the place of X they have given P and in the place of Y we have capital Y. So these are the values of independent variable and these are the values of dependent variable. What they are asking, find the law of the form this. That means they want a relation between P and Y in terms of equation. y is equal to a plus b into p. After finding the relation, they are asking hence estimate the value of y when p is 150. So to find an equation of this form, first we need to find the values of a and b using the normal equations. Let us consider the solution. The normal equations associated with this type of linear equation are given by. Let us write down the normal equations. How do we write? First will be summation of y. Then we write constant into n, which we have already seen and learned. That is a into n we have written here. Then plus b into, we write plus b into summation of p we write here. Yes, we have written. Then how do we write the next normal equation? Just go on putting p, multiplying p. Let us see. See, we have put here p, and here we will not write n in the next step. We write only a, and we write the summation of p plus b into summation of p square. One p will be multiplied. So these are the normal equations using which we can find the values of a and b. Here you can see n is 6, the number of observations in the given data are 6. As we require in the normal equations, summation of p, summation of y, summation of p into y, summation of p square. We have framed the table. Let us substitute these values in the normal equations. Then the first normal equation will give this. The second normal equation will give this on substitution. Using the scientific calculator, you can find the values of b as a is equal to this and b is equal to this approximately. Now let us substitute the values of a and b in the required linear equation as they have given. So the value of a we have put here and the value of b we have put here in the linear equation as they mentioned. Now they want us to find the value of y when p is 150. So let us substitute the value of p as 150 now. Yes, when we take p is equal to 150 in this expression, we get the value of y as 0.66. So this is how we found the value of y when p is 150. This completes the problem. Now let us take the next problem. Fit a straight line to the following data. Year, production in tons, means in the year 1961 the production is 8 tons. In the year 1971 production is 10, and so on. They have given the data. First of all, they are asking us to find a straight line which fits this data. After finding the straight line, they are asking also find the expected production in the year 2006. That means in the year 2006, when we go for the extended year for 2006, we want the production, expected production we want. Let us go for the solution. Let year and production respectively be represented by the variables small x and small y. That means year we are representing it as small x and production it as small y. We shall fit the straight line in the form y is equal to a plus bx. See, in this problem also they have not mentioned the equation. We ourselves have decided to take the equation of the form y is equal to a plus bx. Now, since the values of x are very large, you can observe here 4-digit numbers are there for x. So when you go for x square, it becomes more. So we need to simplify the given data first and solve the problem. How do we simplify the given data? How can we reduce these numbers? Let us see. So here we choose convenient origin. That means we select one middle value. And go on subtracting the values. We go on subtracting the values. Like, let us see how do we do that. What is the procedure? See, here we have taken the middle value 1981. Now what we do, we subtract 1981 from every value, and we denote the resulting values as capital X. That means 1961 minus 1981, whatever value we get, we assign it to capital X. Then we go for 1971 minus 1981, and this will be 1981 minus 1981. It will be 0. Let us see how do we subtract and form a table. After that, since we have changed our small x to capital X, we need to write in the place of small x capital X for now. Later we will substitute capital X back by small x minus 1981 after finding the values of a and b. Now let us go further. Now here note what they are saying. If the data was up to 1991 only, suppose in the problem this observation is not there, then how do we select the middle value? We select the middle value somewhere around here, that is 1975 we can take as a middle value of 1971 and 1981. We have taken middle value. You can take the average also, or approximate integral number you take. Now the normal equations associated with this type of equation are as follows. In the place of small x, we have to take capital X in the normal equations now. Yes, see, you can see here Instead of small x we have taken capital X because our variable for now is capital X. The second equation, and n is equal to 5 here. Let us form a table to find summation of small y, summation of capital Y, capital X, summation of capital X into small y, and summation of capital X square. Yes, as we discussed, we are writing all the values of capital X by subtracting, that is small x minus the middle value. If we do, we get all these values. You can check, and the values they have given in the question as required in the table: capital X small y product, then the summation. We multiply the capital X and small x values, capital X and small y values, and x square column will be given as others. We square all these values. If we square, we get this as a summation. When we substitute the values of summation of capital X, summation of small y, summation of capital X into small y, and summation of capital X square in the normal equations, the normal equations reduces to this. Because of this 0, few terms will get vanished. Now what is a from this? We get a as 11.2 and b as 0.16. Substitute these values, and along with the values of a and b, we will replace this capital X by small x minus 1981, because for our convenience we had used this substitution small x minus 1981. Now we have to replace it back here because we want the equation in terms of small x and small y only. Yes, we have replaced the values of a and b and capital X as well. You can see here we have replaced. Now we multiply this 0.16 inside and add with this constant value after multiplication and simplify to get this equation, which is the required best fit for the given data. And they want the future prediction in the year 2006. What is the production they want? So in the place of small x we have put 2006, and we simplify this using the calculator to get 15.2 as the production. Hence expected production in the year 2006 is 15.2 tons. So this completes the problem.